Hello again. Good morning, everyone. I will have to continue our lecture. Suddenly, the electricity went out, so I will start to continue, inshallah, our lecture today. See, once more, I'm talking about the ordinary depth equations. Most of the sources, notes, and references, you will find them uploaded on Canvas, as I have stated previously many times. In the previous lecture, I started with you with the homogeneous solution of ODE. I want to check this method. Let's resolve it again in order to regain all the necessary steps for solving such a problem. First of all, you will remark that this equation, it's not going to be able, we are not going to be able to solve it using the separation method. I will have to go through the homogeneous start to check that. شباب خلي بالك المسألة دي أنا مش هقدر أحلها عن طريق السيبريشن اوف فاريبلز. ببساطة ليه مش هقدر أحلها عن طريق السيبريشن اوف فاريبلز؟ لأن أنت عندك الارجيومنت of sec, the angle of sec contains y over x. So you are not going to be able to separate all the variables with respect to all the y variables with dy and all the x variables with respect to dx. It's not going to be accessible for you. So what to do? I will have to check if it is possible to solve this equation using the homogeneous method. Let's see the first step. I will have to make this check. If it works, we are going to be fine and we will be able to solve this problem. Let's see. First of all, I will try to make the check that I told you about, and we already saw previously, but we didn't continue solving this problem. Okay, let me see. Now I will make the check. I will see we have already f of x y, which is equal to sec y over x plus y over x. I will make the following substitution. I will replace every x, I will replace it with lambda x, and every y, I will replace it with lambda y. And this will be the following. Now I'm getting f of lambda x and lambda y, which is going to equal to. If we try to do this, you will have sec lambda y divided by lambda x and plus lambda y divided by lambda x. This is the problem that we are talking about. Remark that they will be cancelled. The value of lambdas will be cancelled. So we will have f of lambda x plus lambda y is going to equal to sec, and then the lambda will be cancelled altogether. You will end up having sec over y of x plus y over x, which actually regain again the main form of xy. So now f lambda x, lambda y, we are exactly the same like f of x or y. So this problem can be solved with the homogeneous solution. Okay, I want to go through how to solve using the homogeneous solution. I will make a substitution. ايه السبستيتيوشن اللي انا هستخدمه؟ بكل بساطه انا هعمل الاتي. انا هاجي اقول ايه؟ انا هاجي اقول ان الريبيتد تيرم، التيرم اللي فيه مشكله، I will try to assume. So let's consider let y over x is going to equal to u, which is simply can be rewritten as make a cross multiplication. So you will have y equal u times x, that's y dash equal u dash x plus u. Now في الوقت الراهن انا دلوقتي خلاص عرفت ان y بيساوي u times x وعرفت ان y dash بيساوي u dash x plus u. Next step ان انا اعمل ايه؟ I will try to make a resubstitution in this problem. بص بقى كل اللي انا اعمله، اخد المساله بتاعتي دي وهبدا اكتبها بالنيو فاريبلز بتوعي. طيب ده معناه ايه؟ معناه ان انا I will replace y dash of x دي هشيلها واحط مكانها u dash x plus u, which which is gonna equal to sec u plus u. Remark, once ان انت عملت السبستيتيوشن بتاعتك، once ان انت عملت الريبليسمنت اللي انت بتتكلم عليها، هتلاحظ ان الاتي in u from the left hand side is gonna be cancelled with the right hand side, and you will end up having, instead of having addition and subtraction, you will just have u dash times x will equal to sec u, which will develop اللي هي هتخلي لك ان انا اقدر to rewrite this ODE to be in the form of du by dx is gonna equal to sec u بالشكل اللي احنا شايفينه. طيب انا دلوقتي عندي du by dx، ما تنساش ان في هنا x. I will try to rearrange those terms, make a cross multiplication. If we did a cross multiplication هيبقى الشكل بتاعك عامل ازاي؟ يبقى الشكل بتاعي عباره عن x times du and it's gonna equal to sec u, okay, sec u times dx. All I have to do is to rearrange your terms. So once more, I will take du from the left hand side divided by du. Don't get back with an empty-handed. So I will have to move dx by x. So the result is going to be du divided by sec u, which is going to equal to dx, which is going to equal to dx divided by x. Now we succeeded in separating the variables. Once more, I will try to integrate both sides, each side separately. That's an دلوقتي لو انا بدات اعمل integration for both sides، يبقى I will integrate the left hand side and I will integrate the right hand side. You will end up having اللي هيحصل دلوقتي ان انا بعمل integration for cos u times du, which is gonna equal to the integration of dx by x. That's gonna get to, you will have sine u equal ln x plus a constant. This is the general solution that you have if you want to have the main constants, the main variables, I'm sorry. All you have to do is to make a re-substitution. Instead of dealing with this problem, I can rewrite it as the following. أقدر أكتبه بالشكل الآتي. ده عبارة عن sin y over x، ده الساين بتاع y over x، والكلام ده هيساوي ln x plus a constant. يبقى أنا جبت الجنرال سوليوشن بتاعي simply من غير أي مشاكل whatsoever زي ما حضرتك شايفين. خلي بالك، the problem starts, it's unseparable or the ODE. Once you start assuming that x equal 1 x and y equal 1 y, once you start making your substitution, the problem will, you have a successful check for the homogeneous method to be working. The second step, I will make the substitution, the supposed substitution. Then I will try to cancel out the terms from right to left. The problem will be separable. I will treat it as a separation of variables and voila, the problem is solved. المسألة بتاعتك تتحل، مفيش أي مشاكل whatsoever. تعالوا بصوا كده. Let's quit this slide. وتعالوا نشوف how it is written with you. I'm looking for my pen. Okay. Once more, this is the main problem. First, performing the homogeneous system check. Let's replace lambda x by lambda x as we saw previously, and y by lambda y. Once you do this, you will end up having f of x or y will equal f of lambda x lambda y. Once we try to do the check, as you see, we reveal the main function, it's like that. So it's homogeneous and ODE. So all I have to do is to make the substitution that u equal y over x. Let's make a cross multiplication. You will have y equal u times x, as you can see. The next step is to find y dash. Let's differentiate both sides with respect to y. So it's going to be y dash u dash x plus u, as you can see. Let's make the required replacement or substitution. So you will have u dash x here. I've just replaced y dash by u dash x plus u. So this is going to be sec u plus u, as you can see. Now I can cancel out u from both sides, from the left hand side and the right hand side. You will have u dash x equal sec u. Let's rearrange this equation. So you will have du by dx times x equals sec u. If we want to rearrange, let's make a cross multiplication. Upon arranging terms, we will end up having du by sec u, as you can see, which is going to equal to dx by x. Let's integrate both sides. The left hand side with respect to u, the right hand side will be with respect to x. Integrated because u is going to develop sine u, and it's going to equal 2x plus the constant. As long as you have ln x, let's replace the integration constant by ln a as we treated previously. We will use the property that ln a plus ln b is going to equal to ln a times b. So this part is going to be ln a times x. So you will have sine y over x equal ln a times x. We are done. This is the general solution. If you want to make further simplification, I can take arc sine for both sides. So you will have y equal x times sine minus 1 ln ax, and you have you plot them in a perfect manner. Okay. Also, this is one of the very, very famous problems that we can also solve using this method. As you can see, first of all, it's considerable. How can you separate it? How can you get all the x variables? Are you with me? Okay. How can you get all the variables with y on one side with dy and the rest of them to the other side as f function in x times dx? Unfortunately, you're not going to be able to do this. So what should we do? What should we do? Okay, let me try this. Let me first do the check that I told you about. See, if I won't solve it, I will try to solve it with you first, and then I will show to you how it is written in your handout, which I have stated previously. It's on campus. Okay, let's see. First of all, I will try to check if the homogeneous method or is it going to be successful to have it separable, reducible to square root. Okay, I'm going to consider that f of x and y is going to equal to y, which is x plus the root of x y. Okay, let's get f of lambda x plus lambda y, which is going to equal to lambda y divided by lambda x plus, this is the square root of lambda x times lambda y, which is going to equal to, this is lambda y divided by lambda x plus, this is the square root of lambda square x y. Let's take lambda square outside the bracket, so we will have that f of lambda x plus lambda y will equal to lambda y divided by, this is lambda x plus lambda to the root of x y. Let's take out lambda from everywhere, so this value is going to be cancelled altogether. It means that this value means that we will have y divided by x plus the root of xy, which is exactly like f of xy. The check is successful, so we can really now do homogeneous solution steps. Okay, I'm very comfortable with the form. I'm really very comfortable with the form of y over x equal u that will develop that y dash, let's take it a little bit step by step, which is going to lead to that y is going to equal to ux. That's y dash, it's going to be u dash x الكلام ده plus u. Let's make this substitution in our function. يبقى إذا كل اللي أنا هعمله المسألة بتاعتي أهي، أنا I will replace y dash of x by u dash x plus u, which is gonna equal to let's replace y, okay, by u times x. So this is going to be u times x, which is going to be divided, oh, wait. I will have first to find y over x, which is going to be simpler than substituting in this form. It will be durable to use it, but it will be much easier if you use the main substitution. Okay, let me try it this way. I've never tried it. I usually seek y over x in order to make the substitution. But yeah, I think it's durable. This is x plus, this is the root. I will replace y by u times x. So you will have x squared times u. That's u dash x plus u is going to equal to ux divided by x plus x times root u. Okay, we can cancel out those terms. So never give up. You shouldn't give up. U dash times x, the plus u will equal to u on the denominator. On the denominator, you will find 1 plus root u. Okay. Okay, I can move this value of u to the other side. So I will end up having du by dx, which is going to equal to u divided by 1 plus root u minus u. As you can see, this is the main problem that we have. Du by dx is going to equal to u divided by 1 plus root u. Positive u from the left hand side will be moved to the right hand side on this manner. I can get a common denominator just to do a simplification. Now we are succeeding. As you can see, we have all the u functions on one side and the du by dx on the other side. So all I have to do is to try to make this arrangement. So we have du by dx, which is going to equal to the common denominator will be 1 plus root u. So you will have u minus u times 1 plus root u. Never give up. So it's going to be u minus root u divided by 1 plus root u. These two terms can be easily cancelled together, a positive and a negative. Then I will try to rearrange my problem to be on the following form. I will have du, as we did before, divided by this negative root u over 1 plus root u. I will take those from the left hand side to the right hand side. So it's going to be du, just a second, let me use another pen. So it's going to be du, open a bracket. All the right hand side I will move to the left hand side. So it's going to be 1 plus root u divided by root u, which is going to equal to negative. Dx will go to the other side, so it's going to be negative 2 dx. Now, in such a case, we will have the following: 1 over root u plus 1 times du, which is going to equal to negative dx. Now I can integrate this part as 1 over root u, which is u to the power of negative half. Once you integrate it, you will end up having 2 root u plus u, which is not equal to negative x plus the constant of integration. I can resubstitute instead of u by y over x. So your problem will be 2y over x plus y over x equal to negative x plus c, and here is the solution, the general solution of this problem. See, the steps are the same. The steps are the same. I will also show you another type of substitutions that can work easily with such problems. See. Okay, let's quit that. Okay, perfect. Let's see how this is written. As I told you previously, here the function. I've tried to divide the denominator on x. That's to retain the main form, y over x. You can do that. So it's going to be y over x divided by 1 plus the root of y over x. Let's try to check, replacing every x and y by lambda x lambda y. The formula will be the same. So it's a successful check. It's going to be lambda y by lambda x. They will cancel each other. Same way like in the denominator. So we will end up having this check is correct. Let's assume that y equal y over x. That's y equal ux. That's y dash equal u dash x plus u. Let's substitute in the above equation, replacing y dash by u dash x plus u. So it's going to equal to u divided by 1 plus root u. In a similar manner, I will try to move u from the right hand side to the left hand side. So u dash u dash x will equal to u divided by 1 plus root u minus u. Try to get a common denominator for both of them. Once we are trying to get a common denominator, you will have u dash x, which is going to equal to u by 1 plus root u minus u. Try to get a common denominator, as I told you previously. So this is the form. If you try to simplify the denominator, u and negative u, they will cancel out each other. You will have this form. Let's make the substitution, as I told you. I'm sorry. Let's move them to the left-hand side and move the other to the other side. You will end up having this equation. I will integrate it and define the solution, as you can see. Okay? The details of this solution, you will find it on Canvas. There's no problem with that. For the remaining part of this build, I would like to go through something. Just give me seconds, please. I will erase this part. Just a second. Okay. Once more, I want to continue with you. Okay. In a similar manner to the homogeneous, still this part is, you can find it in 25 and 40. There's no problem in that. Still, everything you can be found on Canvas, so you are in good shape. And as I told you previously, our recorded sessions, as we know, it will be uploaded down the road on the YouTube channel, and you can access it from the playlist according to your wishes. Okay, still, I want you to remember the message of solutions that we stated before in the solution of ODEs. We have the separation of variables technique, we have the homogeneous reducible distributive. Both of those we already saw in the previous lecture. And I will go through the exact method, the linear and only on another web. I will try just to tackle the exact ODEs for you today in order to see how to deal with these equations. But first of all, I want to review with you these two equations by giving another example on the homogeneous solution that we will see shortly. Let me regain this slide again. I want to show you the problem that, just a second. Okay. Just a second. Okay, here. As I told you, I want to check with you again and show you how to go through homogeneous differential equations with another substitution. This is also one of the famous problems that you may encounter in some cases. If you have y dash, which is not equal to whatever, let's say cosine x plus y, one of the famous problems that you can find. First of all, if you try to take a look for this problem, it's not going to be stable. You can't separate this problem. You can't get the x variables on one side with dx and the rest of the variables to the other side with dy. It's really very difficult to do this. But, okay, let me start with this. Okay, let me check. I can do a substitution here. Although it's not going to be, it's not like y over x at the same steps, but let me try to do this substitution. I will assume that u will equal to x plus 1. If I do this, I'm really seeking to find y dash. So in order to make the replacement, so I will differentiate both sides with respect to x. That's y u dash will equal to 1 plus y dash. That's in y dash will equal to u dash minus 1. I will take this substitution and this substitution and I will try to make a resum in the main differential equation. لو انا خدت التو كونديشنز دول وحاولت ان انا to resubstitute in our differential equation ايه اللي هيحصل بالنسبه لنا؟ Okay, I will replace y dash by u dash minus 1. So I have u dash minus 1, which is going to equal to cosine u. Okay, perfect. So that's u dash will equal cosine u plus 1. This is a separable, can be handled as a separation of variables. دي من الميثودز الظريفه قوي اللي اقدر اعملها فيها يعني some trigonometric substitutions very nice. Okay, once more I will try to get rid of u dash. So it's gonna be du by dx, which is gonna equal to cosine u plus 1. Let's make the replacement, rearrange the terms and so on. That's, we will have du divided by cosine u plus 1. On the other side, you will find dx. Okay, how to integrate this? Without substitution, if you remember, yes, if you remember, we have a law that states that cosine 2x will equal to cosine square x minus 1. That's in cosine square x will equal to cosine 2x plus 1. This is really looks tempting. We can say that cosine square u over 2 equal to cosine u plus 1. As you can see, here the angle and here is twice the angle. I can use this replacement, which actually it's gonna help you out in this integration. So if I use this relation here, the integration will be, this is going to be integrated too. I will replace this part by cos squared u over 2. This is with respect to u. And the other side will be integrated with respect to dx, which is, you know that 1 over cosine squared is going to be c squared. This is really works very good. So I will have the integration of sec squared u over 2 times du, which is going to equal to the integration with respect to x. Once you start with wait, I will put it just on the right form to be integrable for me. So instead of having u over 2, I will multiply by half, and this is 2. Okay, then it's going to be 2 for 10 u by 2, which is going to equal to x plus your constant. The problem is solved now. It's 2 of 10. Let's replace u by the first substitution. Let's make a substitution. So it's going to be y plus x divided by 2, and this value equal to x plus c. This is the problem that we are talking about in this general description. This is one of the very nice problems that you can see. This is really a very nice problem. Okay? So, at the time being, you saw how to make a separation of variables, a successful separation of variables. Step 2, how to use the homogeneous differential equations. And we already solved this problem, which really looks tempting to us. Okay, let's get back to our schedule or to our arrangement. Once more, I did go through this slide before, the separation of variable technique, homogeneous. Now I'm willing and I'm hoping to speak with you about the exact first order differential equation. It's one of the very, very famous techniques. I'm going to use the exact forms if the problem is not separable and if also it's not homogeneous, and it's difficult to me, for me to make a certain substitution that will make everything works out easily. Okay, let's see. If I want to solve an exact ordinary differential equation, the problem should be on this form. First of all, your problem should be on this form. Certain function x or y times dx plus another function times x or y times dy, and it's going to equal to 0. If you succeed in having something like this, the check for the exact method is really very simple. الطريقة بتاعت الاكزاكت اللي التشيك بتاعها اللي يأكد لك انك تقدر تسولف البروبلم دي using الاكزاكت method انك to find the term that's multiplied by dx differentiated with respect to y, and the other term that's differentiated that's multiplied by dy differentiated with respect to x. That's, I will try to get partial n, partial y. And I will check if it's equal to partial n, partial x. It's vice versa. The term that's multiplied by dx gets differentiated with respect to y. And on a similar manner, just a second. And in a similar manner, the box that's multiplied by dy gets differentiated with respect to dx, and see how it's going to work. Okay. Once this is settled, you have a successful check, then I will use the following. I will consider just only one part. لو المسألة بتاعتك نجحت والتشيك بتاعك مظبوط, I will take one of these two terms, either the part of n times dx or the time of n times dy. I will make the integration. Don't you ever forget that you make partial derivatives, so I will have to add a function in the other variables. So if you are integrating with respect to x, you will have to add a function in y, and vice versa. If I choose to integrate with respect to y, I will have to add the variable in a constant, which is going to be a function in x. This is the solution, this is the general solution once you succeeded in determining the value of q. The steps, I'm telling you about those cases. The steps is once you find the solution, I will differentiate it with the variable that I didn't integrate to, then I will check partial u, partial y with the term of n of x or y. If there is terms that exist in n but not exist in u, this is going to be equal to the function that I'm seeking to have, which is k dash. I will integrate it once more and do the substitution, and I will obtain the solution. I know it looks a little bit complicated, but once you started the steps, it's going to be easy. Let's see. I want to solve these problems. I will start with the first one. Let's see. The exact differential equations are really very easy to determine or to choose this method. If you try to log, it's impossible to separate the variables in these two brackets. As you can see, there is addition and subtraction between various terms, so it's not going to be easy to separate them as x function times dx, which is going to equal to another function in 1 times dy. It's impossible. As you can see, there is addition, there is then x, there is then y, so it's not separable. If you try to check the check will be homogeneous, no, it's not going to work. Simply, this is what we're going to develop lambda to the power of 4, and this is going to develop ln x divided by ln y, so it's not going to be homogeneous. There is no repeated terms that I can assume, like the previous problem in the final solution. Let's check what we are talking about if it's going to be solved by the exact answers. Okay, follow me, please. This problem is very, very important for you. Okay, I will check to see if the exact method is going to work or not. Okay. Okay, let's see. Okay, so this is the part that I'm going to call it M, and this is the other part that I'm going to call it M. So I have now M, which equal to ln y over x plus 2 over 3xy cubed. M is multiplied by dx. So let's get my. I'm gonna try to get my, which is gonna equal to. If you try to make a derivative for y, with respect to y partial derivative, considering the x as a constant, I will start with the first term, which is m. That's gonna develop 1 over ln y. Then I will make a derivative for the other variable, which is the other ln, which is gonna develop 1 over y. So just differentiating the first term in m, it's gonna develop 1 over x, which is actually a constant. The first with the arithmetic function, it's gonna be ln over y. The second ln, it's gonna be y. So you will have m sub y, which is 1 divided by x times y times n. For the second part, it's very, very simple. All you have to do is to find the derivative for y to the power of 3, which is going to be 3y to the power of 2. So it's going to be 2 over 3 times 3, which is going to be 2x y to the power of 2. Now we succeeded in finding m sub y. Let's get the value of n sub x. خلينا بقى نمسك الان اهي وليتس differentiate it. هي already with respect to times dy. I will differentiate with the other variable, that's x. If we try to differentiate with respect to x, so it's gonna be 1 divided by x y times then y. The other part I will try to differentiate with respect to x, so it's gonna be